Hello, this is the first video which I have uploaded on my new archive channel. The footage is a couple of years old and I have learned one or two things since then. Now I would do a lot of things differently than I did them back then, so don't judge me too hard on the details here. The idea back then was to build an electromechanical device which could serve as an experimental driving platform for RC cars as well as for autonomous robots. Since this was my first attempt at building something like this, I had the wise foresight to call it Project Prospector I because I already thought that there would be a Prospector II at some time in the future. I used some parts from an RC toy car at first and replaced them by self-made gear step by step. The first thing I did was to take several receiver circuits from the toy cars and added relay stages over which larger motors or other loads could be attached. Today I would do this in a completely different way, but it was sufficient to test the principal behavior of the driving platform. I later also built analog radio control circuits from scratch. Since I had roughly 1 million salvaged DC motors lying around, I finally wanted to use one of them for anything. I took one of those chunky DC motors which you can salvage from some printers, as you can see in my video about that. That meant that I had to build a gear train by myself. Since of course the frequency of revolution of these DC motors is much too high, while the generated torque is much too low to be directly applied to the wheels. I made the gear train from structural steel plus some nuts, bolts and washers. The cogwheels were from a lot that I had scored on eBay years before. In retrospective, they were the most expensive parts. Here you see a test run of the gear train in an early stage. All the work was still done back in my old workshop. After testing, I welded the frame of the gear train together. Later, I also installed protective aluminium sheets on the bottom. To test this first part, I hooked it up to the steering system of one of the RC toy cars and made a first test run. I also put some LEDs on it. This contraption was powered by the lead-acid battery which you see on the top. But I also wanted to experiment with a simple steering system which I decided to build myself as well. It worked similar to the front fork of a motorcycle. The steering system was powered by a DC motor based warm drive which I had salvaged from an old VCR. Because of the primitive receiver circuit, the angle of the front wheels could only be controlled by a method you could call manual pulse width modulation. To test the steering system, I temporarily connected the back drive and the steering system with two simple pieces of wood. As you can see, it worked in principle. But of course, that ugly wooden construction had to be replaced by a real middle section made of steel parts. That involved some welding. But please don't look too close at those connections I made back then. To hold a chunky lead-acid battery, which of course is a bit heavy for a mobile application like this, I also made a battery compartment out of aluminium. To join it with a steel middle section, I also had to do some hand tapping. After joining these three sections and putting the receiver circuit on top of the vehicle, it was now ready to drive. But with the heavy lead-acid battery on board and due to the heavy steel construction, the motor did not deliver enough mechanical power to move the vehicle with sufficient speed. Therefore, I added a boost converter circuit which stepped the input voltage of 12 volts to a stabilized output voltage of around 45 volts. The boost converter I used was one of those car laptop chargers I also mentioned in my SMPS tutorial part 3, which I recommend you to watch if you want to know more about boost converters. To set the output voltage to a value higher than the normal 18 to 21 volts needed for laptops, I simply had to exchange one single resistor on the PCB. But in this way I also made my first experiences with the meaning of electromagnetic interference. The switching noise that was produced by the boost converter debilitated the functionality of the receiver circuit. After shielding the boost converter inside a Faraday cage, I also added several LC filters to suppress the switching noise. But due to my lack of knowledge in the field of filter design, I finally added a second battery that supplied the receiver circuit, while the main battery only supplied drive and steering system. This solved the problem. With the boost converter installed, I then tested the vehicle extensively. It could cope with grass, and it could climb up hills, but had still problems with certain terrains like loose soil. But after some time, the Prospector developed a mind of its own and drove away into the sunset. No, just kidding. To be true, I don't even remember why I stopped working on the project back then. I guess it was because I had so much other things to do that I somehow lost track. But there is still a chance that there will be a Project Prospector II sometime in the future. If so, then I will let you know about it. So, if you liked this video, please watch my other videos and check out my other channel, The Post-Apocalyptic Inventor.